Assalamualaikum warahmatullahi wabarakatuh. And hi everyone. Today my innovation is What's Up? Explore circuits with Ohms. My name is Maira Imani binti Lokman from Emerson Langkawi. My advisor is Madam Fatin Fakiha and my team member is Myrza Iman bin Lokman from SMK Jitra. Today, I'll be talking about one of the most fundamental principles in electricity and also electronics, which is Ohm's law. Ohm's law is named after the German physicist George Simon Ohm, who first discovered the relationship between voltage, current, and resistance in the early 19th century. This law is simple in expression, yet extremely powerful in its application. It tells us that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance of the conductor. In this presentation, I will explain the basic formula and its meaning. By the end of this session, I hope you will not only remember the formula but also appreciate how such a simple relationship has shaped modern technology. So now let's begin. There are five things that I'm going to talk about in my presentation. The second one is objectives. The third one is methodology. Fourth, results and impact of innovation. Fifth, conclusion and also future work. Crucial parts of our daily life. Understanding how voltage, currents, and also resistance are related is fundamental in physics. As we know, Ohm's law states that voltage equals to current times resistance. I designed an interactive simulation using SketchUp to help students visualize and explore this concept. As a motivation, many students struggle to understand how electrical components interact in a circuit. Traditionally, diagrams and also static teaching methods can be abstract and hard to relate to real-world changes. There is a need for a more engaging and interactive tool to demonstrate Ohm's law in electric circuits. There are three objectives of my print demonstrates the relationship between voltage, resistance, and also current. The second one is to help students visualize how changes in resistance, current, and also power. The third one is to provide an interactive learning experience using Scratch programming for students. Now let's move on to methods. First of all, we should generate some ideas. Brainstorming based on syllabus topics which are Ohm's law, power equation, series, and parallel circuits. You should also identify the need for an interactive tool to help students visualize how resistance affects current and also power. Choose Scratch as the platform for its simplicity and also suitability for secondary students. You can also help students to visualize more about this. Second, planning and design. Identify key physics concepts which are Ohm's law and also power equations. Outline, outline simulation flow and also sprite interactions. Thirdly, development using Scratch. By using Scratch, you can build the simulation. You can also create variables which are voltage, resistance, current, and also power. It is a programmed dynamic calculations and it can also give visual effects. Fourth, testing and also troubleshooting. We can adjust resistance, voltage using sliders. By using sliders, we can increase or decrease the resistance. It can observe real-time updates in current and also power output. Last but not least, verified formulas and also behavior match physical theory. To do this method. First, start out with some codes and then add some sounds and effects. Third, movement and also sounds. Fourth, now variables and also controller codes are the main component of Scratch. As a result, displayed how current decreases when resistance increases and also vice versa. It can also show changes in power output based on resistance settings. We can also include visual elements, which is a slider, to enhance students' understanding. Students are able to experiment with different resistance values using the slider. Students can also instantly see how currents and also power values change. It can also connect theory to visual output. Now the impact of my innovation is the effectiveness are the simulation made abstract concepts more concrete. Users could interact and also observe cause-effect relationships directly. Now the educational impacts are it can support inquiry-based learning. Second, it encourages self-paced exploration. And last but not least, it supports SDG for quality education, digital literacy, and 21st century skills by using technology scratch in STEM education. To conclude, my innovation to demonstrate Ohm's law, which is voltage equals to current times with resistance. It also demonstrates the power equation, which is power equals to voltage times with current. Students could visually and interactively understand how resistance affects current and also power. Lastly, it encourages self-paced, visual, and experiential learning, which is especially helpful for students with different learning styles. Future is something that I can add to my innovation. I can add switches and also bulbs to enhance the effect as the loop changes. Can also focus on series circuit only because it can expand to include parallel circuit and series parallel circuit. Develop quizzes or challenges to test and also to enhance the understanding of the students.
Hello. We are going to learn about Ohm's law. Ohm's law is defined as relationship between voltage V, current I, resistance R. Let's see Ohm's law in series circuit. Series circuit, you can vary using slide of the voltage V and resistances R1, R2, R3. That's the voltage across resist. You can conclude that in series circuit, voltage is maintained the same while current is different depending on the changes in range.
In conclusion, Ohm's law may look simple as voltage equals to current times its resistance, but its impact is huge. It gives us a clear and also reliable way to understand how voltage, current, and also resistance are connected. This law is not just something we study in textbooks, but is applied in almost every electrical device and also system that we use in our daily life. From the smallest electronic gadget to massive power grids, engineers and scientists depend on Ohm's law to design, test, and also improve technology. Without it, modern electronics and electricity as we know them would not exist. I hope this presentation has helped you see that Ohm's law is more than just a formula. It's a foundation of electrical science. That's all from me. Thank you.